Let's start our next unit, kinematics in one dimension. Just think of kinematics as motion. Before we get started, everybody knows we begin all these units with a lab, and every lab needs to be written up in your notebook. You're going to make sure you have a diagram of the apparatus, labels, data tables, the whole works. And you're going to have to make a graph with labels on each axis, include the units. It's all set up right here for you. Kinematics describes motion without regard for its cause. But you probably already know that to put something in motion, you have to push on it. Well, that's not part of this chapter. So we're not going to worry about the force that causes it. We're just going to look at the motion itself. We've already talked about displacement earlier on, and you can read this. It's got some good examples. You already know something about velocity. So we already have the background to start the lab. And that was going to be a velocity of a toy car, but you don't have a toy car, but you do have a steel ball. And you also have a ramp with a bevel. It's got a groove in the middle. We're not going to roll the ball down from the top. We're going to roll it down from much closer to the bottom. We're going to mark 5 and 10 centimeters on the wooden ramp. Then you're going to find either a table or set this up on the floor just so that you have a nice flat track to let the ball roll down. And I've marked off with my markers every 20 centimeters. You can use anything you want to mark this off. Here's what the whole track looks like on my table. I had to put a book under here to level the table so the ball would roll straight. I'm going to release the ball so that the front of the ball is lined up with the 5 centimeter mark. Now, when you release the ball, you're going to record that with your cell phone. You can then upload the video to YouTube, play it back at quarter speed, and time it with your stopwatch. You'll measure the time it takes for the ball to travel every 20 centimeters. Then we're going to do it again from the 10 centimeter mark. So making sure we do things correctly for this lab, we're using a steel ball. We're going to measure 5 centimeters up the ramp, mark it, and put the ball so the front of the ball is at that mark when we release it. You're going to video the ball moving along the table. When you upload this to YouTube, you can play it back at quarter speed, use a stopwatch, and time how long it takes to get to each one of these marks. You can just hit the lap button at each one of them. When you play the video back in slow motion on YouTube, make sure that the times that you get are going to be divided by 4 so that you can put in the correct time. Start at a time of 0. You're going to have to figure out how to do that. Remember, the time is supposed to be cumulative, not just a time to go from one mark to the next and then one mark to the next. It's the time running from the beginning. Now, if you think we're going to have some error here, you're right. It's all going to average out. You're going to plot this data on a graph. Make sure you start at 0, 0, and make sure that the spacing is even. No breaks. Make sure you have distance on the y-axis and time on the x. I'm sure that you can see that you're going to get data that will be a little scattered, but do you think that 0, 0 should also be included? Yeah, absolutely. At time 0, we're supposed to be at the start. Does that data look like it's a linear trend? If the ball is moving at a constant speed, yeah, that should be a linear trend. Now you're going to want to find the velocity by looking at this graph. What on that line would give you the velocity? I don't want you to use the individual data points. I want you to use the line. So you're going to think about that. Then you're going to move the ball up to the 10 centimeter mark. Make sure that you put the front of the ball just behind the mark. And when you release it, you're going to record it on your phone, upload that to YouTube, and then do the same thing all over again. Now, the data is not going to be the same, obviously. The ball is going to be going faster. You're going to get another set of data points to plot. I'll let you figure out what that looks like, but get the velocity for both situations, and then plot the velocity versus time on a separate graph. We'll pool all our data on a Google spreadsheet, and I'll make a class graph for you. Good luck, everybody.